Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Here we are. Very excited to have you on today, Jason. And I've been quoted saying this, and I'll say it here, transmission is my first love. So, when I got into the industry, I was all transmission, and I definitely understand the power of our conductors. But with that, I'm going to give it over to you to kind of introduce yourself to our audience, and then we'll get started with our conversation today.
Yeah, Liz, thank you very much for the opportunity to speak with you today. With your statements, transmission, we're talking to the right audience. TS Conductor is all about power grid. I am a co-founder and the CEO of TS Conductor Corporation. I used to be in aerospace for many years. Before I got involved with conductor business, I did aircraft design work for quite a few platforms, 787, A350, F-35, F-22s, F-18s. And in 2010, I had the opportunity to go to Advanced Conductor, and I did. For an interesting reason, I felt at the time composite material, especially carbon fiber composites, has reached its pinnacles in terms of aerospace application. The fuselage, the wing structures in the aircraft are using carbon fiber composites. But when you look at power grid, the conductors, they're still using steel as the strength member in the conductor. This could be an opportunity to make a difference in that industry. So I made that change, and I joined this industry in 2010. So that's 15 years ago.
And I think a lot has been going on in the last 15 years. Some may say not enough. Some may say we're moving faster than ever. I mean, we are only a 140-year industry. But a big part of grid modernization in its name is really looking at the fundamentals of where we were, where we are, where we're headed if we don't maybe change our reality, and then where we ought to be. So I'm really excited to have the opportunity to explore this technology that, is becoming available, is becoming adopted, and just get into the nerdy details, because I have noticed we do have audience that love the technical granular details. So don't be afraid to get nerdy while we talk. But you kind of mentioned a little bit, of your journey. You were in one industry, the aerospace, and then you realized that there's something that, with your expertise, your knowledge base, your information, another big thing about the Grid Mod Pod is all about continuous learning. So you found a niche, right? There was an outreach for you to pivot. But, explore really, what has that journey been the last 15 years and adopting this technology and thinking through, what it can be and whatnot.
There are some themes in there. I would like to elaborate a bit. First off, the industry that we're in, it is so conservative. It's in a different level. I thought aerospace was conservative because people's lives depend on it. Boy, am I wrong on that. After I joined the utility area, that we're trying to get technology adopted by utility industries. It has been a very slow process. But when you understand why utilities are risk-averse, why they're slow in adopting new technology, you have a degree of appreciation, and you have a understanding how to work with, first being a regulated business. And risk is just, a strange word, a phrase. Nobody in this business likes to take on risks because the regulators don't allow you to take risks. And I think that's first and foremost a character we have to keep in mind. The second part, I have to say that for the most part, for the past 15 years, load growth hasn't been a theme. And so there's really not that imperative to modernize the grid until the past, I would say, 4 or 5 years, that people are waking up for the need to do energy transition. And most recently, you got data centers, AI, that is driving load growth besides factory onshoring. And that is suddenly becoming a necessity for utilities. If you wanted to attract business to your service territory, you have to have the power supply to support them. So that is another characteristic I would say we have to keep in mind, that even though our industry is used to moving slow, but we probably don't have that luxury anymore. We're being compelled by other mega trend to move a lot faster and probably do things at a pace that we're not used to in the past.
Being in industry, what I heard is, for 15 years, you come over, you more or less are asked to help, take over and run a company that does what. So let's get into the TS.
Yeah. I was recruited to join a company, I don't mind names, CDC, to be in charge of their technology area in 2010.
So, and I'm going to rephrase that. So you were overseeing a company that was using, that carbon fiber technology, which is different than the typical conductors that we're mostly used to, which is steel. And from my knowledge, when we talk about reconductoring for our listeners, we're taking transmission lines and or, any kind of facility that has the poles in the ground, you have the right of way secured, you have the substations on both ends if it's a networked system, and you're taking down the old wire and you're putting the new wire. And I think just the fascinating fact, and maybe this is more is with the new material, you can have 3 times more capacity in that conductor and it be lighter, which is a huge, feat from those engineers that are in the back offices being like, our line's getting overloaded and we need this capacity in like a year or two, but we don't have time to upgrade our voltage, which would require a whole, transmission rebuild, towers included. You could actually run this conductor in various, spaces. So that is like a tool in really the grid's toolbox when thinking about meeting this future capacity. So kind of back to what you said is 15 years ago, there wasn't a significant load growth, and maybe like the technology that you spoke of, there's the capability, but then the ease of installing becomes a big indicator of success in many industries. So what you found, that it was brittle, etc. But now you evolved into this new advanced technology, a conductor that isn't. Is that what I'm hearing?
Yes.
And with the load growth more like exponential due to all of this desire for data centers, there's now this opportunity that you're kind of highlighting and seeking. It's very exciting. So I guess my question is could you explore the advanced conductor in general and what is the attributes?
Yeah, maybe before I explore that more, let me give you a little bit of the history of how conductor technology evolved over the years.
Love it. Yeah.
And that will kind of really give you the complete story. If you look at the wires in our power grid today worldwide, I would say super majority of those wires are based on ACSR conductor, which is aluminum conductor steel with that R reinforced. And what is in ACSR, which was invented in 1908? Think about that. This is well over 100 years old technology. It is simply combining high-strength steel at the time with hard aluminum. And you might ask, why hard aluminum? It's not the most conductive type of aluminum for a conductor. Well, the reason is very simple. We need the strength contribution from the hard aluminum to complement steel because the steel at the time was not that strong. And the problem is when you use hard aluminum, they have a temperature limit. That temperature limit in material science is 93 degrees centigrade, because if you go above that temperature, the hard aluminum gets annealed into annealed aluminum. You lose strength, you have sagging problem. That temperature limit is what limits the capacity or transmission capacity in ACSR conductor. And that's why our power grid has that bottleneck issue today. So fast forward to the 1970s, Liz, the steel industry was able to offer stronger steel. Now you can make a conductor that leverage stronger steel combined with annealed aluminum for high temperature operation. So when you can go to high temperature with a conductor, you naturally are able to carry more electricity. So therefore you have higher capacity. The problem though with steel in the core, they expand when hot. That's what creates excessive sagging problem. So ACSS is not the perfect solution. If you go to high temperature for high capacity, you have to address the excessive sagging issue. If you do reconductoring, just use that as example, you have to raise all the tower height, which is going to cost utility more money and more time, outage time as well, to get the project done. Some may even require permittings to do that work.
So when we're saying ACSR, it's aluminum conductor steel reinforced. And then I think you also said, I mean, all aluminum conductor was AAC. And I think you're throwing out another acronym, which is
ACSS.
Which is the advanced conductor acronym?
Yeah. Well, I look at as part of the traditional conductor category because they are still using steel as the strength member. So the way I look at conductors, the real innovation in terms of advanced conductor comes when we moved away from ACSS, which is still rely on steel. By the way, ACSS stands for aluminum conductor steel supported.
Supported, yes.
Supported. And so the emergence of advanced conductors started in the 1990s with composite material of lower thermal expansion to replace steel. So you don't have steel in the conductor anymore. Now you are able to address the thermal sagging issue that we had with steel in the core. And in the advanced conductors in the 1990s, we have two notable developments. One is a 3M product called ACCR, which is using ceramic fiber as the core material, which has lower thermal expansion. And that allowed the conductor to go to high temperature for high capacity, but with a managed thermal sagging. The other conductor that emerged around the same time as well, late 1990s, early 2000s, is called ACCC from CDC. It is simply using glass fiber, carbon fiber, hybrid composite core to replace steel. It can also manage thermal sag. It can go to high temperature for high capacity. But both these advanced conductors, they have not had very positive experience when utilities try to deploy them, namely in the conductor handling aspect, that the line crew find them to be delicate, difficult to work with. You bend them, they're easy to snap. And that is a major issue. And one of the things that our industry is conservative is about safety. You know, any utility you walk into, safety is pretty much the theme.
I just have to share two relative stories just to put some relative. So like, as I said, my first, transmission, my work was gather the power system models. And then within the models, you have your point A to point B, so your substation. And within that, you have your RLC, resistance, inductance, capacitance. And that is taken by mile, so like, a unit per mile. And then you would have to know the particular conductor. So you become very familiar. There's like a book, little huge matrix, that many impedance per mile. You make sure it's correct. So it's a very laborious and labor loved to fundamentally have the whole transmission model modeled and then have the accuracy of those conductors. But on top of that, I also had the experience of, when all of those acronyms that we rattled off, there's various ratings and voltages. So you get a whole display of, and maybe we'll throw up a visual here for our talk, but you literally count the amount of strands and also look at the shape. So let's say these conductors go up on the wire and you have to inspect them, you can actually count. So that is when we think about what are the field engineers or the operations folk do it, they fundamentally have to go and inspect to make sure the right conductor size is in the database to run these models. So I'm just trying to like the power of like, okay, we come up with this beautiful new technology in the 90s. We're like, we could push more capacity. This is a great idea. And then we start rolling it out as an industry and it starts having some issues in the deployment. Well, we're slow moving, like you said, we're conservative. So that experience kind of lives on. So I feel that now we're coming to a new, right, advanced conductor that you're going to probably dive into. How do we overcome, what happened in that revolution and then also adopt and move forward? So
that is the challenge for TS. That given that legacy issue associated with first generation advanced conductor, people naturally, when they hear about TS, they were like, so that's a carbon composite conductor. We've used it before. We've never had any engagements because they are lumping TS with that first group of advanced conductors. And what is fundamentally different here, Liz, is in TS, we recognize the fundamental reasons for the lack of workability in the first generation advanced conductor. That is bending. When you have, we're kind of diving into the weeds here. When you have a unidirectional composite, if you pour in the tensor direction, let's say, imagine this pen is the carbon fiber composite, should be black, but it's white. But nevertheless, if you pour tension on it, they're super strong. Why? Because all the fibers are engaged. They're providing strength support. But if you were to do compression on them, like squeezing them, this is a matrix material dominated. Now, the compression strength is only about 60 to 70% of the tensile strength. So why does it matter? Well, if I bend the conductor into a curvature, which happens when you're doing installation, half of the material under the neutral axis, which is the center of the conductor, below that center line is in compression because they're getting squeezed. The upper half is being stretched. It's always going to fail prematurely on the compression side. That's the vulnerability. So what did TS do? Well, to address that vulnerability in compression, we actually pre-stretched the carbon core. And to preserve that, we actually had to figure out a way to keep that pretension in the carbon core. That is the aluminum encapsulation protection that we use. Now you have a situation where if you were to bend the TS conductor into the same curvatures, you do not automatically create the compressive stress on the underside like the first generation advanced conductor are subjected to. This is similar to civil engineering. We do pre-stressed concrete, and it works at the same exact principle. It works. And with that, we address that vulnerability of bending fractures. But more importantly, we also kept all the degradation mechanisms out. For example, we keep the moisture out, we keep the oxygen out, we keep the UV out, we keep the ozone from corona out, because these substance cannot enter the carbon composite core because of that aluminum encapsulation protection layer. And that layer of aluminum encapsulation also makes our conductor compatible with traditional way of doing conductor installation. Same tool, same equipment, same methodology, same training. We don't have to train linemen. We don't have to send an engineer on job site to supervise their work. And you don't need to call TS if you have to do maintenance work or even repair because of weather emergencies. And that is important. So if I were to draw a pyramid in terms of technology adoption in our industry, you need to deliver on performance advantage. Like, well, we can do 3x capacity expansion. We can also cut line loss by as much as 50%. That's important. That's on the performance. You also have to deliver cost savings to the ratepayer, because if you do reconductoring with TS, you can do it without any structural retrofit. And what that means is you can do it at the lowest cost, fastest time possible. There's also economics associated with line loss reduction, which you could say, it's a green dividend. Oftentimes people think about green technology, there must be a green premium. Not necessarily the case with TS. You actually get savings. The third of that pyramid is what I would call safety, reliability, and the workability aspect that the utility and the line crew must have with your product. If you cannot deliver that third aspect, it's not going to go very far. And we've been blessed with a great technology that can check the box in all three.
There's so many parallels here, and I feel like I do have, some foundational listeners. So when we think grid modernization, I think as human behavior. We tend to develop language, create stories, package it so we can rinse and repeat. And fundamentally, that's all things in life. But when we think about the electric utility space, it's only been around 140 years. It was something that no one dreamed of and thought it was the work of the devil when light was at night, to now it's the lifeline of society. Yeah. And if we don't have that, we don't even know how to comprehend what life would be like for most those that have the privilege of having such reliable power. And so that evolution of, really engineering, creative thought, innovation, packaging it, we're seeing ourselves in the first 80 years, the evolution, the generation of technology was really stagnant, and really it was what it was, and we drove efficiency and economies of scale. And then we had this lull where we really were trying to drive down our usage. And I guess I'm only sharing this with is like grid modernization. We really put it into this bucket of really physical assets, understanding what they are. I mean, that is core, and then basing the performance of the existing assets, even if they were around for 80 or 90 years. And then the next level is really like the infrastructure that is needed to gather the data, to communicate effectively to all of the various assets. And then very quickly we get into how to manage and operate it. And so I feel like there's been many time frames, but the first gen, the first pioneers, because information moves so fast in our day, and we have many storytellers and we have many utilities, it's really how do you package the really that power of three that you just shared is big, right? Knowing that you need all three of these checked to move it forward. Now the goal is how to educate, inform, and really get the first movers to believe in the second generation. Because like we just mentioned, we kind of had the 1990s evolution, and I think we forget that the rule of first movers, or really those that take that original risk, are assessing the situation. So the goal is to learn from the gaps. And so what I'm hearing you say is that has passed. There's this new potential opportunity where, and I think many utilities are catching on to it, that the first gen has went, lessons have been learned, and a second generation of capability with our conductors, which are, as you said, the bottleneck of unlocking the queue or increasing the capacity of our transmission, because we can go from projects that could take 3 to 5 to 10, even 20 years for a rebuild to within a year if we effectively can identify the problem, create the story, and then drive, all of those positives to the right players to make those decisions. Anyway, I'm geeking out and super excited. So
yeah, thank you. And
we have to remember, right? Lessons have to be learned by doing. And so we've done, and now let's do round two. And I think the parallel to also I wanted to say is AMI, our advanced meter infrastructure at the edge of the grid. We went through one round, we've learned a lot, we're coming to the second round, right? So you can almost see that happening in every aspect of the grid. And so today we're talking about, transmission, but it's there everywhere. So
I agree.
I'm hyped. So, from your perspective, if you kind of map out or the next 20 years, or maybe, it seems that we need all of the answers in the next 5 based on some of this energy demand that we're being requested of. What's your vision, and how do you see moving through these obstacles and gaining traction?
I would put it in several categories. One, we got to really think about the wires that we're using. Whether you do reconductoring, whether you do interconnect the new lines, you got to really think hard about what conductor we should use. Because if we pick the wrong conductor, we're going to be stuck with it for the next 50 to 70 years. And if you pick the right conductor, you will be enjoying the benefit that conductor brings to you, whether it is future-proof capacity, whether it is better efficiency, you will be able to benefit from it every day. That is important. The second part I wanted to ponder a bit more is our industry is heavily regulated. Our industry responds to regulations. So I anticipate that our regulations are going to be more progressive going forward. You look at the most recent FERC order 1920, which includes GETS technology and also advanced reconductoring. And that is the right direction. I would urge regulators and the legislators to go one step further to provide additional incentive to the utility to enable them to make the grid more efficient. And that can be done without any cost. Actually, it's going to be a saving or rate reduction for the ratepayers if we are able to leverage advanced conductor for line loss savings. Because these are freebies and they're not being fully exploited today. That's the second part. In the third part, I would also argue that you're going to expect the conductors going forward to be smart conductors on their own. You mentioned about GETS technology, grid enhancing technologies. We could also do that from the conductor itself.
Mm-hmm.
We have technologies, we have done demonstrations about 6 months ago with National Grid that we can monitor conductor temperature on a distributed fashion. And we can also monitor sagging in the conductor real time at all times by leveraging optical fiber inside our aluminum encapsulation protected carbon core. And imagine the possibilities. You will be able to, from the control room, know how your circuit is doing every feet along the circuit, everywhere, at all times. And if you want to do dynamic line rating, you have that built in because you have that information without relying on third-party sensors because the conductor itself is sensing at all times. And it will also provide better resiliency in addition to reliability to our grid because the extreme weather are going to be becoming more pervasive.
This phenomenon of sagging, that in itself, right? With extreme conditions, keeping the assets where they're supposed to be, knowing that we're going to have hotter days, which means, those lines will dip. So it's another positive. So I guess with the power of three, they say, people tend to remember things in groups of three. And so tell them what, tell them what they're going to tell them, and then tell them what you told them. Reiterate the power of three in regards to the lessons learned from the first round of advanced conductor to now where we are.
First off, what are the threes? Performance advantage, cost benefit, and workability in the field. And if you were to look at first generation advanced conductor, they deliver on performance, but they don't necessarily deliver on the cost benefit because the products are expensive. So they're only used for niche applications. And the third one, that is workability in the field, which is really missing. And that's a very important feature, especially giving our industry's conservative culture and the safety concern.
And even when we say, the industry itself is conservative, which it is, and there's actually three entities that make it pretty, but it's your regulatory, it's your financial, and it's your operational, needs. And so there's your power three. And then even within operations, it's then the three that we just spoke about. So it becomes very complex very quickly. And here we are getting excited and be like, well, why isn't everyone using this? If it's available, the cost is, the analysis is there, the performance is there. There's even been shown of workability. I think that also goes back to the grid modernization kind of trajectory of maturity is the technology is becoming available in masses for many things. The key component I love to talk about is, the people and the processes that will be impacted. And it's somewhat of a catch-22. So when I shared my story about being a transmission engineer and, putting those data into that model, like There's a first mover phenomena that happens in the utility. And I'm going to steal a story that Charlie Bayless told me. But it's the whole penguins phenomena where they inch up to the ice and they all stare into the dark water, pondering if they will be swallowed by the sea lion. And it's really, and he named the penguin Fred. But Fred will jump in, and if the penguin doesn't get eaten, everyone jumps. So, like, you can think of the utility space as somewhat like the penguins. They're all looking for that first mover, that one that can show and prove out those three, which I think TS Conductor has some valuable partners that have done that. But now I think even with everything happening, there's so much happening, even getting that message through, like to successfully share that story is a challenge because of so much is rapidly changing and moving for the utility space. So I just love the opportunity of, just having this platform to be able to share that these stories are happening, the information is being shared, the utilities are being first movers. It just may not seem it because, one, there's a lot of utilities out there and there's a lot of penguins sitting at the edge, but there's a lot of first divers too. I think, you can do a quick Google search to see your partners and those interaction. And why I share that, it's important because that individual engineer that's trying to figure out a capacity problem in this big world of the interconnection world that we all faced with and meeting these surging demands, is it will take a large amount of effort as an individual to champion the procurement of a new typed asset. Like now you're going to hit many departments that need to be told a story, convinced the reality, and then move forward. So that takes time. And so I think, we all wonder like, well, why don't they just do it? But there's like processes that have been placed to bring in new technology, assess it, validate it, and then buy it, have it on site, and install it. So I guess I just wanted to bring that to reality and something you've probably been traversing through as you've been putting these devices on the system, right?
Yeah, I can give you, kind of
Yeah, some success stories.
a success and somewhat a success story that, we have some very blessed investor groups that they're industry visionaries, including National Grid, NextEra, now Edison International, which owns Southern Cal Edison, and Quanta Services. National Grid invested in TS in November of 2021. We did not manage to get TS Conductor type registered until late summer of last year. And we're still working with them on first deployment. And that's how long it took. And this is our investors. And they have been tremendous in terms of their investment folks helping us going through the hierarchy within National Grid. That's how the company is set up because of regulations. And they have to check all the boxes. They have to go through the process procedures. And but I think the end is worth it, that you go through that process. It is a rigorous process. It is also a testimony about TS Conductor. And I'm sure I recall when I was in the other company, it took many more years to get their product through that process. So we have to be patient. Any company that are out there that are working with the utility industry as their customer, they have to have that strategic patience. But as you said, Liz, there are many other companies in our industry. Some of them are real progressive. We have utility customers like SRP, APS, Basin Electric, MDU. We have Florida Power and Light. We have TVA. We have Mid-America, Dominion, ATC. We also have quite a few co-ops as well. And these utilities, they have proven themselves as pioneers, and they have TS technologies that are being deployed. And we also are working with other major utility players. And I think we're going to get there. It's just taking a little bit more time compared to other industries in technology adoption. So you have to be strategically patient. At the same time, be accommodating, be responsive to the established protocol or process until those process or protocol are changed. And this is why I was asking that perhaps our regulations and legislations provide some incentive for the utility to be proactively looking for technology that's going to make their grid more efficient, because they're allowed to keep some of that economic benefit to their shareholders. if the regulation allows it.
Right. And that's like it when we think about mapping out the process. So like for those that want to be the change champions or the innovative spirit is like realizing the complexity of the process itself, right? Like there's multiple steps and there's dependencies. So take the effort to learn them or at least be aware of them. Realize interdepartmental coordination in large, even small companies takes people skills, right? Process and communication, effectiveness. And then the regulatory and compliance stuff, right? Those are they're there for purpose and reason. So like understanding what they are and then how do you be creative in that approach? And then realize, I guess, there's the human factor of fatigue and resistance to change and, just general communication breakdowns. But that is like a part of being a champion of moving new technology, new innovation. It's not like a side effect, if that makes sense. I just share that because I learned a lot and I didn't realize what was happening until I stepped out and looked back and I was like, oh my, right? Like this should be taught. Because maybe, coming out of school bright and shining, and then bushy-tailed and excited, you're going to make a change. And then being a new leader, these are all skills that like really could help move some of this transformational technology forward. Well, I love it. So I always do like to end our podcasts with kind of a summary of, if you were with a bunch of new engineers or, someone that wants to be a part of the energy industry, what's advice that you would give them?
Oh, wow. This is such an exciting industry to be involved because the robust growth that is projected, anticipated by everyone, it's going to continue for the next 20, 30, or 40 years. It's a great industry to make a career in. And also, I would say we all have, one life to live on, which is about 20 to 30 years, or let's say stretch of 40 years of working life. You have an opportunity to make a difference for our world, for future generations to come, for climate change. And it is an opportunity to make a great career. At the same time, you can make a difference for the world. This is it.
I didn't even coach you. No, I love it. Thank you. I totally agree. Well, with that, I'm going to say thanks again for showing up. I'm very excited about this and I look forward to hearing about all the future projects. And with that, until next time, listeners.
And I'll just add one more point, Liz. That TED Talk that I did late last year, it is available. Anybody can listen to it. You just go there and check under Jason Huang. I think it's called...
We'll link it in our show notes.
Yeah, Unleashing Renewable Energy, something like that.
We'll get it on the show notes for all of us so they can big picture. I love it.
Thank you.
My first TED Talk guest, so,
Oh, wow. Okay. Thank you.
Yeah, thank you. Have a good day.
Yeah, thank you very much, Liz. Really appreciate the opportunity to be here today.
Definitely.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.